Okay, we talked about enthalpy. Let's talk about entropy. Entropy is the measure of disorder. Spontaneous processes increase entropy. That just makes sense. Your room does not spontaneously get neater. It takes energy to keep things neat and organized. You will find positive delta S when one molecule becomes two. Because the two molecules can have more different states and more disorder. If I have a bunch of Lego and it's all in one building, then it only has so many positions it can be in. If I destroy the Lego and it's in a million different blocks, then you can have lots of different possibilities. The other thing that delta S is positive for is if we open a ring. So if I have a closed ring and I open it, it can have more states, and that will give me a positive delta S. So let's look at Gibbs free energy, and we'll be combining our enthalpy and entropy. You can draw diagrams that look very much like the ones that I just drew for enthalpy. We've got delta G here, and we've got our reaction coordinates. And we can have delta G of our reactants and the delta G of our products. And we have a line that combines the two. And here we've got a difference in our delta G. This is a positive delta G, and it's endergonic. We can also have, I'm going to go back to black, we can also have our reactants up here, higher in energy, and our products down here, lower in energy, and we connect them with a little line. There we go. And we have a difference in delta G. Well, I guess I'll probably do it this way. Delta G, and our delta G here is negative, and this is an exergonic process. Now our reaction, exergonic means that it's going to be spontaneous. And it's negative. Endergonics are non-spontaneous. Different color. Non-spontaneous, and they will be positive. We keep our negatives and positives straight. Okay, so here's our reaction. We've got delta G is equal to delta H minus the temperature times delta S. This is how delta H and delta S are related to one another. If delta H is negative and delta S is positive, looking at this reaction, this negative delta H will favor a spontaneous process. It will make delta G negative. The positive delta S makes this term negative because of the negative sign here, and so our process will be spontaneous. If delta H is positive and the delta S is negative, then this will be a positive term, and the minus of a minus will be a positive term, and our delta G will be positive, and this will be a non-spontaneous. I'm going to abbreviate here. What if they're both negative? If they're both negative, then the delta H will be negative, but this term, the negative of a negative, will be positive, and so we'll have a temperature-dependent reaction. If the delta H is positive and the delta S is positive as well, then we will have another temperature-dependent reaction. Now, this term will be positive. This term, the negative and a positive here, will give us a negative term, and so it just depends which term is larger. So I'm going to pull this up, and it's a really good time for you all to stop the video for a little bit and figure out if you know the answers to these. All right, so we have an endothermic reaction, so our delta H is going to be positive, for which the system exhibits an increase in entropy, so our delta S is also positive. That gives us a temperature-dependent reaction. If the temperature increases, that'll increase the importance of this term, which is our negative term. So if we increase the temperature, we will increase the spontaneity of the reaction. An exothermic reaction, let's do the next one. So the delta H here is negative, and for which the system exhibits an increase in entropy. So the delta S is positive. So both of these terms, this term will be negative, and this term will also be negative. So here we have a spontaneous reaction. An endothermic reaction, that's delta H, is positive, and delta S is a decrease, so it's negative. So here we have a positive term, and this term will also be positive, so we have a non-spontaneous reaction. Okay, so we have an exothermic reaction here. The delta H is negative. A system exhibits a decrease in entropy, so they're both negative. If we increase the temperature, this obviously temperature dependent. I was thinking ahead. If we increase the temperature, we would expect to increase the importance of the second term here, which is the positive one, so we will decrease the spontaneity.